The year is 1995. Internet has just started to spread. Most people have no idea what it is and what its applications could be. There are about 13 search engines, and they are neither convenient nor accurate. A revolutionary idea about a secret algorithm called PageRank is born, which would be later used in the most visited website of the modern world. But the presentation of the search page is rather primitive. It consists of a dry and inexpressive list of links with a short summary. Today, in the era of information explosion, where people are always short of time and patience, 10 links on a page would not please everyone. We, as part of the Stanford Scholar Initiative, will try to demystify what goes on in finding the optimal presentation of federated search results using the paper Beyond Ranking, Optimizing Whole Page Presentation. Modern search engines build up search page from multiple sources, such as news, images, video, structured knowledge, and business maps. Each specific corpus is indexed by a vertical search engine. So for a given collection of heterogeneous content, there exist several ways of presentation. They could have multiple columns, aggregated content, and different sizes and layouts of images and videos. We want to choose a presentation which maximizes user satisfaction. Through this paper, we will see the evolution of ad hoc search page presentation from the conventional ranked list formulation to an efficient, self-learning, and context-aware presentation of heterogeneous content. Far from the ancient ranked list presentation, vertical search results today can come in different visual appearance, layouts, and sizes. They span across multiple columns and are not restricted to the main catalog. The focus of this paper is on two specific questions. First, how significant is the presentation of information on the search page to satisfy users? And is it able to improve and enhance the functionality of the search engine? And second, to display the search results on a page, is it possible to find the optimal presentation for maximum user satisfaction? The reason why these research problems are important is because modern search engines are expected to be flexible in displaying heterogeneous search results by tweaking around with item positions, image sizes, text fonts, etc. in an expressive form. It is preferred that they don't just use the probability ranking principle because it is known to be ineffective in certain use cases. There is a need to find the best strategy to present a set of items on search to maximize user gratification. Finally, people are spontaneously attracted to graphical results, causing a significant attention bias. Hence, the conventional ranked list formulation is an imprecise approximation for optimizing user satisfaction.
The authors designed a framework which automatically learns optimal presentations for relevant results from data and experimental results, and also proved that the framework outperforms the state-of-art algorithm in federated search result presentation. So, the aim is to find a presentation function that maximizes the user's satisfaction. The authors proposed to solve the page presentation optimization problem using a supervised learning approach. The first extracted page content for specific queries by firing requests, and the backend of a search engine. The core of page presentation optimization is to estimate the satisfaction score for a given presentation of content. For this, the authors needed to get user ratings for different presentation formats. They organized the content by various methods which were possible with respect to the business and design constraints. Effective presentation strategy of content enhances user satisfaction and could be measured in the form of user responses, such as total number of clicks or the duration of staring at the content. In this way, for a given set of heterogeneous content and presentation strategy, the authors computed user satisfaction metric. This concludes phase 1 of the framework, where we have real valued numbers representing the scores of each presentation. In the second phase, the authors formulate a mathematical optimization problem to find the presentation which would give the maximum score and would thus be the optimal presentation. The authors demonstrated the effectiveness of this framework by conducting experiments on real-world datasets collected via a commercial search engine. The proposed approach was experimented through a presentation exploration bucket and tested for a period of 1 year, where 6 months were devoted for training and the rest for testing. User satisfaction score was calculated as +1 for click and -1 for skip. Here are the results of the proposed approach of the authors. The whole page optimization methods outperforms ranking methods because ranking methods utilizes probability ranking principle to rank results by relevance, which assumes a top-down position bias. So let's again have a look at the research problem. User satisfaction is hugely dependent on the content as well as the layout of the presentation. Yes, the whole page presentation framework proposed enhances the usability of the search engine by structuring content and presenting in a way easy for the user to consume. Experiments on synthetic and real data demonstrate that the proposed framework is promising in solving the problem of optimal presentation to maximize user satisfaction.